Hey everyone, welcome to Decelerator. I'm your host, Rob Kennedy, and today we're going to get right into it with my guest, Ryan Henry. Ryan is a venture capitalist at a family office out of Montreal, Canada, and I wanted to have him on for three reasons. First, as a family office, they kind of look at venture differently, and the way that they approach it, they don't have to invest if they don't want to. So it's just a different perspective. Secondly, he's been focused almost entirely on AI startups for the last couple of years, and so he's got his finger on the pulse of what's actually happening around the world. And third, as an ex-operator, he really understands kind of how the sausage is made. We're not going to get into the mathematical levels of artificial intelligence models and the business models, but we're not going to be at the high level that the media typically has been talking about, this whole DeepSeek thing over the last week. So we're going to kind of compare, contrast, see if there's frenemies or not frenemies or something in the middle for this DeepSeek little revolution. And I think you're going to get a lot out of this episode beyond just, uh-oh, we're all going to die from DeepSeek. So without further ado, I hope you enjoy it. And if you do, please tip us an NVIDIA stock if the company exists by the end of the show. All right, Ryan, thank you for coming on the show. Why don't you tell everybody who you are and what you do with your time?
Sure. I'm Ryan Henry. I am a tech investor. I basically run the venture arm for a single family office based out of Montreal. I'm based out of Toronto. And I'd say a lot of my investing, even though we're up here in Canada, is no longer done in Canada. It's mostly down in the valley.
Right. And just leaning on that topic, because people are like, well, wait a minute, Rob, your show is about not necessarily venture-backed paths. I think like one pattern that you and I have talked about before, and I still think exists, was like folks are taking investments not just from traditional venture capital and following that model, or not necessarily bootstrapping. Family office, taking money from a family office is a viable thing these days. Yeah.
It is. And I mean, frankly, probably the most common piece of feedback that I give founders that I talk to is whatever they're talking about. This is not venture scale. It is not something that a VC fund will invest in, but it's a really good tech company, and it could be a good investment for a non-VC fund. It could be for a family office, could be for angels, could just be something that you bootstrap. So it is certainly a viable and arguably potentially better path in a lot of cases, unless you really are the exceptional world-changing VC backable company.
Right. And you could still be mildly world changing, just not in the
Correct.
exponential way.
Yeah.
But
yeah, there's no one right way to raise funding
to change the world.
Also,
I think we're learning that every day, and that is literally the topic of our conversation. So we're not going to dive too deeply into what you do, because we've had lots of really cool conversations I think a lot of people would benefit from. But the one thing that's worth noting is that your business model as a venture capitalist for a family office, you do require or would like venture style returns. That's why you exist. But the funding model is different. You don't have multiple LPs who have a specific time horizon. Could you just very briefly speak to that? Because I think it colors your perspective on the universe and why you invest the way that you do.
Yeah. So as much as I treat how we invest, where we invest, how much we invest like a mini venture fund, unlike a separate actual VC fund that goes and raises a 4-year fund, 4-year investment window fund from a bunch of LPs. Maybe they're raising a $50 or $100 million fund. All of the money that I invest is from that single family office. The principal behind the family office is a guy named Dave Brereton. He himself was a tech founder from the .com days. So he's been investing in angel investing in tech for a while. He invested in a company I co-founded called Wisely. This was back in 2017. And rather than trying to raise a separate fund and trying to go bring in other LPs, which maybe we'll do someday. But for now, it is really on a, let's say, annual basis. I just have to convince Dave that this is still the right thing to invest in, the right strategy to follow. So as long as Dave continues to believe that I am investing in the right things and finding returns, then the strategy we follow otherwise follows the same structure and strategy otherwise that a VC fund would follow. So looking for those exceptional returns, high risk, high reward.
You went to the YC demo day and you saw you do invest in those companies. So first, for our listeners, as of January, I guess as of December, what was cool and hot? What are the patterns that you're seeing in AI companies, at least today?
Most of YC's companies now are AI companies, however we want to define AI companies. Um, I have a particular interest more in the I don't know, harder tech, defensible tech, so robotics or energy, things that not just any, like, let's say, new grad could just go and spin up and compete with. But I think what we're seeing more and more within the YC companies, and kind of everyone being fast followers, are AI agent companies. So basically AI automation.
Hmm.
There's lots of there's so many coding AI agents. There's a ton on the marketing and BDR and SDR side of things. Um, Lots on the finance and accounting side of, so think of any job, any individual job that you need or will need as you scale an early stage tech company, whether that's in the internal operations or in the product development or in the sales of it. All of those jobs, people are throwing AI at and saying, can we just completely automate this, and then can we do it at scale? And you're definitely seeing that more and more and more. And so there's lots of then tooling to support those types of companies building those things. And then if you want to compete at the foundational layer, there's lots of people playing at the foundational model layer. But it's all AI.
When you're going down there, and again, until a week ago, um, the real in theory moats were the AI companies, where they're like, I have GPUs, I have huge sets of training data. So the technology, that is the people with the moat, and everyone else in theory was building a wrapper. And so what that means for the slightly non-technical folks is basically you're building a thing on top of OpenAI, like Zynga built on Facebook. You're entirely dependent on that API and the goodness of the hearts, and them not actually dog food eating you by creating their own version of an automated SDR or whatever. Like, go ahead.
I would actually even go a step further to say most of the GPT wrappers were literally just putting a different UI on top of
Yes.
ChatGPT, but it's still a chat interface and maybe they give it some custom instructions, but literally the product was
Yes,
nothing
yes. The
more.
crappiest version were
Yeah.
literally just like, we added one more like prompt thing, so you could, or a prompt for you. The best of them were using them in the back end, and companies like the ones that you invested in, for example, are like, we're using the tooling of AI, and there's a business problem here. And the ones that are, I think, at the most trouble, which are like directly in the line of sight of where those companies will go, like when ChatGPT or released tasks a week ago. I'm sure
Exactly.
there's a whole bunch of task management startups that died. So last year, the common wisdom was, don't build a wrapper, because you're going to be obsoleted by the models in the first place. Is that how you uh, think about, like, how do you think about companies that say we're AI? Because everyone's doing what they always do, dot
I
AI at
think
the end of all
really
their
the way
things.
that I think about it, and this probably echoes more from the venture side of things, is that you there's certainly the combination of the founder. The founder is a super important piece of all of this. It's never just in whatever the product is. But so let's say you've got a world class founder that you find and they're building whatever. The thing that they're building has to be something that, to your point, probably isn't going to be like something that OpenAI just like obviates next year, makes it trivial next year because it's now built into the foundational model. But also something that they can get early traction in and build a product around. So maybe the first version of their product was a tool, and then that tool can have a bunch of other tools, and that collection of tools is more of a task or somebody's job or hat that they wear. And eventually you kind of keep building up all of those modular pieces, and now you have more of a full product or solution. And so when you're talking to those vendors and looking at those companies, from the venture scale side of things, you always have to remember that venture scale is about finding those exceptional world class, the ones that can be world changing, the ones that could be the unicorns, and very quickly, like they hit venture scale. And so there's lots of good tech companies that could be AI coders or AI SDRs that, if they sell a thousand licenses or something, like that's a viable business, it's a viable product, that's great. But there's again this fine difference between a company or a founder trying to build that and trying to build a lifestyle business or a good business or a not venture scale business, something that they're comfortable with, versus the ones that have that line of sight into, okay, but if I build this, I can build this, and it becomes this, and it changes this, or this trend line is going like this, and if I start here, it's going to be this. It is that much longer term thinking of where it can become, and you're making that bet on what is that longer term time horizon, even though you need them to find traction today or tomorrow.
But then, like, would you, the thing is AI a feature or a product? Like, is it in your mind then these companies are like, I have a product offering? I mean, short of building an AI model itself, which is the product of AI, or like tuning it or, pushing it in a particular direction, which I'm not even sure if that's a product or a feature. Are you like, hey, this is a good business that happens to be better with AI or unlocks these things with AI, but the core artificial intelligence IP is not the thing I
Yeah, I
invest in,
don't.
or how do
I
you think
think
about it?
of AI more as intelligence being added as a layer on top of everything else. Certainly, there is the deep tech side of AI that could be a new foundational model. You could have been the hedge fund that eventually built DeepSeek. Like that. That is a viable path if you've got a lot of money. You're willing to take that risk. Most people aren't playing at the foundational model layer, or the PhD students trying to say, I have a different foundational model that I could, or a different way to train these models. Like there are some people that play in that space, and that is true deep tech AI that they exist. There's obviously tons of money in it. There's then the tooling and infrastructure layer on top of that. So it could be tools that help people train models. It could be tools that help people fine tune models or customize those models. It could be developer tools to integrate those tools into your existing company's stack and add that layer of intelligence. And then separately, there is the application layer that are net new applications that, might be like copies of existing SaaS applications, but they're more like AI native. And so from the ground up, they're thinking about where does AI fit into every single aspect of this. It's not just add a chat box and we'll be an AI company. It's what are we trying to achieve? What is this customer trying to do? What is the job to be done? If we just have an intelligence layer there that can do a lot of that, well, like let's make it do that. Think of any software that you use, even a browser. Like if you want to check your email, like you're clicking on the browser, you're typing in Gmail or clicking your bookmark or whatever. Like you've taken some manual actions. Those manual actions that a human needs to do can easily be automated. And yes, in the past you could automate that with a script, but now instead of just like clicking on a box, maybe it was trying to book a flight. Well, you have to find where the flight is. You've got to compare all the different flights. You've got to compare the times, and maybe there's some flexibility on pricing. There's some nuance to it that a script could never handle. Well, an AI agent can handle that nuance, obviously to a certain accuracy, and now you can just automate that. So things that you couldn't easily trivially script before, now you can. And so if you keep going down that line of thought, every piece of software that you use and all of those clicks and dialog box filling out and templates and stuff and forms that you've got to fill out, well, all of that can just be done for you. Why does a human have to do that? Why don't we just automate that?
Totally. And I mean, like we've seen, using your browser example, companies like Arc that came and went and maybe comes back, God knows, their mobile browser was effectively what Perplexity looks like, rather
Yeah.
than just shrinking Google search to a teeny box. It's like, let me do the thinking and gathering for you. And Perplexity does it now. ChatGPT search does that, where it's like a different way of using that
Well,
tool.
and
I
that
still,
search is such a great example because in the past, like, yeah, Google has gotten really good that if you're searching anything on Google, probably one of the first few hits is going to be the answer, unless it's some super
it'll be an
obscure
ad. And
search.
then, yeah, I'm sorry.
Sure, it'll be an ad in it.
A
But
page of
wouldn't
ads.
it be better and more fulsome and more complete if I have a model that can click on literally the first 100 links
Yes.
and summarize what it's talking about and figure out, oh, it's actually this link that is the better one that has your actual answer because I understand the nuance and context behind your answer, and then just gives you the answer. And
Right.
in the exact same time that it would take you to do a Google search and click on that thing and find the answer in the web page, you probably already have the answer from an AI based search. Like it is just strictly better.
But feature or product. It feels like it's a feature that's being, the product is whatever the product, it's like an iteration of what a browser is, but an AI powers it. But like, they're no, the entrepreneur is not probably building AI. They're taking AI, they're adding business logic or doing some stuff. Maybe they're tuning it in a particular way, but it's not like they're not creating IP, right?
So the way there's not an answer to this, but I guess the way that I think about the difference between feature and product, if the product folks that are watching understand the job to be done product framework, but if you think of whoever the person is, what are they trying to achieve? Like, what is, so somebody's doing a Google search, they probably have a question they need an answer to. So that job is, and it is a standalone job, find me the answer to this question. And so from that, I would say, well, that can be a product. They have to obviously figure out how to monetize this. Google had ads. AI isn't going to have ads in the same way. Whereas the feature things might be the actual, like, doing the search across 100 web pages. Like if I built a tool that just searched across 100 web pages and summarized them, but then gave me the summaries and I still had to look through that. Well, that's not the product. That's still the tool. And I apply that same line of thinking to whether it's the AI SDRs or AI marketers or whatever they are. What is the job to be done? What is the customer trying to achieve? The product is that whole task, whereas the features are the little tasks or hats that have to be worn in order to do all of those things. And it's not a black and white answer. At different scales, that changes. For different size of companies, that changes. But I do try to think about, like, who is the customer? What are they trying to achieve? Is that a product today, or is that a series of features or tools or tasks today that can ladder up to that product tomorrow?
So what's so interesting about the time we live in right now is that from an artificial intelligence perspective, you and I have talked a lot about the business model stuff, which I think is more fun. So like, let's start with there and let's talk about the models too. So, you know, the what strikes me is that, like, even though ChatGPT came out, OpenAI has been working on this problem for a long time. As you said, ChatGPT, I think 3.5 ish was the
Yeah.
zeitgeist moment where you really saw Turing test like and all that stuff. And then in pretty short order, we had, like, you know, uh, Anthropic, which are related humans, Mistral in France. We saw, like, obviously Apple slowly catching up. Google already had
Are
it. They were
they
just scared
catching?
about using it. Tons of companies, Perplexity, tons of companies just like magically came out with these AI LLM type things. And clearly, to me, that meant, like, in the old days, if this was a technology play, this was like everyone invented calculus at the same time. And clearly it was not a technology play. Clearly this is a capital play. Like, if you gave me 20 billion, I'm sure you can scrounge that up in the family office. We could start an LLM, notwithstanding last week. We could theoretically start an LLM. It's a capital problem. It's not a position or a distribution or owning the market problem. It's not actually fight. It's not I can do a thing that you can't anymore, which I thought was kind of surprising. Do you agree with that?
To Yes and no.
Okay.
So there's certainly the hardware mode. In order to build
Sure.
these massive scaled models, you need access to a massive number of H100s or GB200s now.
Mm-hmm.
And unless you have many hundreds of millions of dollars, like, you're probably not going to get enough. But let's say you do. Let's say you raise all that money. Once a new model has been released, once GPT 3.5, once GPT 4 was released, you, even if it's not actually fully open sourced and you can't see the weights and you can't see all of the code behind it, it's easier to get a sense of how it was built. And that becomes even easier, obviously, if it is open sourced and if we're sharing knowledge. So once the model exists, it's easy to replicate. Easy. It
Mm-hmm.
costs time and money, and you have to have a good data set. And there's lots of fine tuning there.
Sure,
I'm not
sure.
trying to trivialize this, but it's
Yeah, yeah, yeah.
easier than building it the first time. And I'll just talk about OpenAI. As OpenAI built for GPT-4 and then 4.0 and then innovated and released O1 and now O3, each of those releases had fundamental innovation, technical innovation, and then obviously a different scale. I think 4 was probably maybe the least innovative. I don't think there was new architecture from 3.5. It was just at a fundamentally different scale. For 4.0, there were new innovations. There's lots of AI research that's going on in terms of how do you build these new models. And I think we'll eventually talk about DeepSeek, and they did actually have some fundamental innovation, but also kind of took in all the latest and greatest research that had been done, and that's what enabled them to build a new, better base model. And then for O1, you had the new reasoning, and how do you get reasoning from a base model? So O1 is just built on GPT-4, so it's a worse model than 4.0, but now you've got your chain of thought reasoning, and how do you build those models? O3 is just the 4.0 version with chain of thought reasoning. GPT-5 will come out soon. They're in the middle or near the end of training GPT-5, and that probably involved the latest and greatest innovations. But also then another scale increase in the training time and the number of GPUs that they're using. So you can keep scaling these up. And NVIDIA, Jensen Huang has talked about the 3 scaling laws of AI. And I think when we talk about those foundational LLM builders, those AI companies, whether it's Claude, Mistral, or OpenAI, or DeepSeek, innovating on any of those dimensions or increasing the scale on any of those dimensions will get you a new model and make you competitive. There are lots of people that might think, well, that's just a race to the bottom. If someone like DeepSeek can come and fast copy your model as soon as you release it, like what moat is there? But OpenAI's goal is not the next best model. OpenAI's goal is AGI and then ASI in whatever terms that means to them. They're going to keep building these models. They kind of don't care that somebody can build a better version of GPT-4o at the same time or within a month, because they'll keep building the next one. They'll keep building the next one. Each one that they build does unlock new innovation, does unlock new things. And as long as they keep leading, they will probably have customers continue to use them. That's OpenAI's moat, is that they
would you not argue that at some point, if you push 7 buttons and pull 3 levers and you get to whatever a definition of artificial general intelligence is, AGI, and then artificial super intelligence, ASI, why wouldn't all the other companies be fast follows? And then to what end financially?
Yeah. So I think this is the way that people have talked about it a lot in the media lately as well, and especially with DeepSeek. It's like, oh, now you can train a model for $6 million. Like, I guess you don't need a Stargate's $500 billion to train the next model. It was like, no, that's just a really good model, but we want to build the next one.
Yes.
And I think the challenge of thinking from OpenAI's perspective of so I'm trying to think of where this line of thought was going. Can you ask your question again?
Yeah, totally. Like, cool. So AGI, artificial general intelligence, ASI, artificial super intelligence. If those are the next steps, first of all, like, everyone would just fast follow. They'll figure it, like, they'll find what the steps are. And we'll talk about how DeepSeek became DeepSeek. I don't think it's just $5 million and a new algorithm. There may be other aspects of it. But like, what is first of all, why wouldn't all those companies fast follow as they've done with everything else, like Meta and all those companies? And then secondly, cool, but still, what's the business model?
Yeah. So I think when you talk about like the goal of AGI and ASI, I'll bring it back to what we were talking about with the AI SDRs, and that if you only have 2, like, that's great. If you have 10, that's better. If you had infinite, well, that's a different scale. And I mean, only on that dimension, that's obviously better, but having infinite might open up all of these other dimensions.
Yes.
And so even if OpenAI's goal is AGI and ASI, and other people have a similar fast follow goal, they don't care to be the first, they don't want to spend as much, but they think that they can get there as well. Now we have 2 models, 2 companies with AGI models or ASI models. Apply the same thinking. Well, what if we had 10? What if we had 100? Does it matter that there's a limit there? If you only think about the existing problems today, the existing tasks today, the existing jobs today, then you say, well, all those get automated away and ta-da, we're done. But that's not the end of technical innovation. if I ran a school and I could bring on 100,000 more PhD students and do like net new innovation,
Hmm.
you're probably going to find new things. We're going to
I see what you're
create
saying. So
new things.
it's not
Is there an end to that?
right. It's not necessarily reaching that point. It's the things you do with it, like curing cancer. If Google's for
Exactly.
Gemini or whatever they call it, ASI or whatever, accidentally cures cancer, then that's cool because they got there first and they figured out how to do it. Even if
Now,
somebody
there
else
is
comes.
certainly the argument to be made where most of OpenAI's revenue today comes from the consumer level using ChatGPT. If I mean, you see it now with DeepSeek. If somebody can create a as good version or almost as good version, and it costs them a dollar instead of $30 a month, or it's free instead of the $30 a month, people will. I mean, efficient market hypothesis. People should move to those, and will eventually move to those. And yes, so I think OpenAI and the leaders in the AI models do need to be aware of like where does the eventual revenue come from. It could be that OpenAI is like, well, we love the consumer revenue today, but then it'll be business revenue, and then it'll be fundamental, like we'll solve cancer, and then we'll solve, I don't know, space travel and so on. Like,
Yes.
I think that's like it's a harder argument to buy into, but again, this I think is the difference between maybe that venture scale versus the I just want you to build a solid business today. OpenAI is on the venture scale path. There will be people who keep funding OpenAI because of what they can unlock tomorrow or in 10 years and that potential, even if there's only a 1% chance that they achieve it. Whereas if you are the fast follower and if you're going to raise money as the fast follower, you're probably going to find investors who want you to be a viable business today and capture that revenue today. And then now you go down that path of, but where's the moat and how do you compete?
Yeah, like totally. There's arguably first mover advantage here, especially here. And I mean, I don't think OpenAI makes any money. Yes, they're bringing in revenue for B2C, but they're probably burning
Oh, they
more money
burn,
than Uber
yeah.
ever did.
Well, because they're training
to
the next massive
right.
model.
And we know that the deal they made with Apple in both directions cost, at least we think it was $0, because the only thing you want, like Apple wants something that's smarter than the thing that they can make. And ChatGPT just is distribution, man. If we own the hearts and minds of people, it's worth getting the users. So they're thinking definitely long term. Um, but just unpacking, just I want to unpack the moatiness still about the models and how they train them. So like the way I understand it is effectively OpenAI vacuumed up the internet before people figured out what was going on, trained their models, and then that's it. That's the end of the internet. And then I don't know what the statistic now, but used to be it was like you're creating an internet's worth of data a year. I'm sure it's more than that now. It's probably faster. But like diminishing returns, right? You don't have the infinitude of time. You have the large amount of data, but it's not infinitude amount of time to then train on. So how how do they keep you told it when you skipped over the history of OpenAI, but how do you keep if you don't have infinite amounts of data and you do have a lot of GPUs, how the heck do you make these models better?
Yeah, there's a couple dimensions here. So one is you do kind of have infinite data. And you alluded to it. We as humans are constantly creating. We're recording this video right now. This is net new data that a year from now, there will be a
I won't
point where
monetize, but boy, will OpenAI make a lot of money on it.
there will be a point where we are creating so much new data that is on a yearly basis that is more than all of the other data combined. Like it will just keep accelerating. So the people who argue that we are running out of data, I think miss that. Like, no, we are creating a ton of data. The important bit in that, though, is you don't just want more data, you want more high quality data. Now we have to talk about, well, what is high quality data and how do you filter out all
So
of
that is a
the.
direct insult to the show. This is low quality data. So you
Sure,
want
yeah. I didn't implement. Now, in the past, we used humans to annotate and label this data. And when we talked about high quality, useful data, it was only, again, what a human scale could do. And it used to be that the thought of using synthetic data would lead to a model's collapse. Basically, if you train on AI generated output, that eventually your model comes to this generic soupy garbage that doesn't actually create anything net new. I feel like we've I'm not saying that's not a problem at all, but for the most part, we understand what might lead to model collapse of AI generated data, and it really has opened up the world of actually creating and using synthetic data in training. And I mean, DeepSeek themselves, this was a huge innovation that they had, which we can talk about. As soon as you start opening up that door of synthetic data, AI generated data at AI scale, really, if you want to talk about like the running out of data problem, like I don't, we do have infinite data.
Yeah, and then there's like, I mean, we've before the show we talked about this before. Like, I was like, explain how synthetic data can actually how you can train on synthetic data, and I used the example at least when we met before about like, how do you know 5 plus 3 is 8? If no person is annotating it, and you want to explain how that works in the synthetic data world to actually work?
Yeah. I mean, if it's sometimes hard if you want to use like very trivial examples, like three plus
Sorry.
five is eight, but only because there is an answer to that. And so where you're talking about math and where there is an answer, you would probably just use a reinforcement learning model to be like, okay, did it get the right answer? This one got it. Okay, try another problem. Did it get the right answer? But that is different than the supervised fine tuning, where you want human annotated labeled data that has context and nuance and all of that. And so, maybe a better example is just, let's say, a text summary of this episode. You probably have good enough models today that can take a verbatim extract of all the words in this show, summarize it, and then even summarize it again. And you could then use another model to say, well, did that summarize it correctly, or give me a score of 0 to 1 of whether it was good or whatever. And you can build different models that compete against that. So there's a whole dimension of AI research that goes into figuring out how do you get high quality data, and what does high quality data look like, and what does that spectrum look like? It's not always just black and white. And you have to apply that thought across all dimensions of data, whether it's math, whether it's physics, whether it's humans talking in an interview, whether it's humans talking in person, whether it's a marketing bot talking to another marketing bot, whether it's legalese, different dimensions within the legal world. So there's so much nuance in the data that eventually you want experts, the AI experts, across all of these dimensions. You can go super fine grained, even down to when to use the right punctuation in different languages. Like the level of expertise that we as humans think would be like, well, can I get a PhD on that? Okay, I'm an expert. But like, you can just keep applying that to very, very fine grained, nuanced things, and eventually you want experts. And there probably is no end to that. Like, if you want to build the taxonomy of all information and all knowledge in the potential like history of the world and future of, like, there is no end to that. We are talking about infinite amounts of data. At some point, the hope and theory is that you get to the AGI and ASI with enough of that, but there really isn't an end to the amount of high quality trainable data. Um,
But also, like you've said to me in the past, and tell me if I've mischaracterized it, let's use math just as a simplistic example, because I think we all know I don't really like going to say ChatGPT to ask it math questions because it seems to, I don't know, I'm not sure if it's going to be right. Um, the way I think we talked about it at one point in the universe was, you know, from a probabilistic, I'm like, I was like, I don't understand how 5 plus 3 is 8. And you can just, as an example, and how you can just say, I'm not going to supervise you. You just go off and keep feeding yourself the same data. And eventually it'll be cool. And I think the explanation you gave to me is like, from a probabilistic perspective, 5 plus 3 is 8. Sometimes it'll say 9. Sometimes it'll say 3. But from a
but
probability
most often it'll
distribution
be
curve,
correct. Yeah.
it's going to be 8. So probabilistically, that's how it knows that the answer, I'm, using that term loosely in this particular case, it's math, but it can be something that is not quite as black and white. The right answer is that from a probabilistic perspective.
I'm sure the PhD researchers would like hate me for that type of explanation. but yes, if we simplify a training curve, and how does it know that it is correct? If it gives a probabilistic answer, well, once you get close to the right answer, more and more of the answers tend to be the same because it is the correct one. But even if you have a model that almost always gets the correct one, it might sometimes make an incorrect one. But
Sure.
it's still like, you always have to think at scale and that and kind of probabilistically. It's not where we run a math problem through like through old school computers where it literally calculates 5 plus 3. It is like it's kind of guessing at, in the same way that you or I might guess at what is 7 times 8. What's the first number that comes to your head? You'll kind of be close. The more you do it, the more you'll get it right. But every so often you have a bit of a relapse and you're like 2. And you're like, okay, I know that's not right.
But it's more memory than compute, right? Like we know 7 times 8 because we've learned our times tables. I'm not flipping bits in my head. So
and this is actually what you see in many of the models as well. Like if you ask it like the simple math that you or I might be able to do in our heads, it gets most of that right. If you start asking it like 100-digit number multiplied by 100-digit number, it's probably going to get it wrong. But now it's good enough to know, okay, I can't solve, or I don't just know that system one thinking. I'll use a tool. I'll just open up a calculator and then I'll give you the answer. Because like we as humans, when we're asking it, I don't care how you get the answer, but I do want it to be right. We're trying to build these models to know, do you have the information? How confident are you in the information that you've generated? If you can't generate it, okay, can you use a tool? Can you correctly identify the tool? Okay, if you've correctly identified the tool, can you break down this problem to solve this? Now we're getting into the chain of thought reasoning. Now we're getting into all the reasoning models.
Right, but even the dumb, like, keep refeeding the machine the same thing over and over again. If it's, again, using my dumb example, 888-998-8888, eventually it's like the answer is clearly 8. So it'll weight towards 8, even though it doesn't understand that it's weighting towards 8. That's how you don't need to have an annotator. That's why you don't need to scrape more data. The synthetic data is enough. Again, very simplistic example. I get it. Because the thing that's weird to I think people, to your point, is like, how do you not enshittify the data to the point where it's starting to vomit out wrong answers because no human is intervening? That's the part that I found I struggled to understand.
So a good example of that, just before we maybe dive into DeepSeek and chain of thought. If we take a base model, and if you think about how do you know, or how is it useful today? Like say we are using GPT-4o, just like base model, no fancy application around it, and we just ask it, like we feed it in a software problem, we feed it in a function, and we're like, there's a bug in this, can you fix it? Let's say arbitrarily that 50% of the time it can fix that. Without changing the underlying model, and without knowing whether it is right or not, we can take its answer and ask another copy of 4.0, well, is this right? And if it's not right, okay, go and fix it. Like we just keep going down this iterative loop.
Yes.
And if we just arbitrarily say it's 50% accurate, well, after 4 iterations, we're now up to a 90% confidence interval. If we add another one, we're at 95. Like if we get it to, if we do 10 iterations, now we should be 99.9% confident that it is correct. Like these are logarithmic scaling things. And even if one is inaccurate, we'll just do it again. And a lot of the early tooling and application builders that were trying to improve GPT-4o were using these types of techniques to just be like, well, just ask yourself, is it correct? Just use another like verifier. And then it became more complex to build like verifiers of verifiers, or you're an expert in this and you're an expert in this, and pass back into this. Like you start to build all these like systems of, they're just a bunch of like different AI, the same base model AI, but you're playing on the probabilistic side of, can you do it? Did you get it right that first zero shot?
I think that's what's weird. So first of all, it's like if you go throw something over to Claude or to Mistral or some other weird thing, it sort of makes sense intuitively that they're like, however they got to make the sausage, they are different. So it is intuitively like, it's like asking for a second opinion from a different doctor. They were trained on the same stuff-ish, different life experiences. The weird conceptual part, I think, is when you ask, are you sure you got it right? Which I've done on very basic questions. I remember I asked it an rsync question. I'm like, what's the recursive directory format thing? And it's like, bleh. And it's like, aren't you missing the recursive part? And it's like, oh, yeah. I'm like, why am I supposed to do this? You're supposed to know this. So intuitively, it's weird to ask the thing whether it got it right or not.
But we've now seen that this works. This was I don't want to say innovation, but this was like what led to OpenAI building O1 versus GPT-4.
So what is the difference? Explain that difference. That's super interesting. Because
so
can I
you
just say
have
one thing? Like the thing that the core difference to me is that math is math. And I think people just don't understand probability intuitively. And so if you just feed in probabilities over and over again and you increase the confidence, I think that's part of a lack of our human intuitive understanding of what probability really means. Anyway.
As long as there is an answer, and as long as we're not talking about independent coin flips, like I don't want to upset
Sure.
the math
other
people,
thing, other kind of probability as well. Sure.
But maybe the easiest way to think about the difference between the base models of GPT 3.5, 4, 4.0, 5 versus the reasoning models O1, O3, now DeepSeek's R1, and some of the other ones, is not much different than what we just talked about. So if you want to build O1, well, you take GPT-4 and you basically build a simple iterative recursive system that says, okay, well, are you sure? Was it right? And there's lots, you can add some complexity to it. You can try to apply some human logic to this and try to build a smarter one. Though I think we've found with even what DeepSeek is doing, that it actually doesn't need to be any more intelligent than that. But you do it enough times, and you end up getting the more accurate, better version. And it's not as simple as like just asking, like, are you sure? Are you sure? Are you sure? Think about it more like building a tree. You ask it, are you sure? And you ask this other one, are you sure? And they spawn their own multiple models. And eventually it goes down, like some of these paths will be wrong and they'll just like either not be able to get the answer or give the wrong answer. And other paths are correct. And now you have kind of another model, another just GPT-4 model on the side. That's like, okay, from all of these potential options, which one's the best one? Like which one actually answered the thing? Okay, now summarize it. Now come back to me. And the reasoning models aren't much more than that. In the, like, as soon as GPT released 4, people started innovating on like this chain of thought reasoning and other types of reasoning. And it almost doesn't, it now almost doesn't matter which of those paths you went down, just using those basic reasoning, like structure of reasoning on a simple system one answer, like what does your gut intuition say is the answer? Okay, but now if you thought about it for a little bit more, like just think about it as just try it again, just keep going and just keep trying. It is just as simple as that. And you just get fundamental new emergent properties in those models that are just better in certain things. It's not better at everything.
I think what always weirded me out was the fact, like, I think when I looked at the API and stuff like that I found kind of depressing. It's like when you're asking the follow-up question, it just feeds the whole damn prompt and then your follow-up, because it's like a fish. It doesn't remember the thing. It doesn't actually, quote unquote, remember. You're just feeding it in a longer prompt, which is, I guess, why those context windows matter, because the prompt size could only be so big and then you ran out of prompt size. But it is also fascinating to me that you're like basically like, yo, think about it. Obviously think is a euphemism for what it's doing. It's not thinking in the way that we think, not to say there's not thinking. But it's basically like, you're saying O1 is try harder and O3 is no, really try harder. Basically.
Well, no. So the difference then between O1 and O3 would be a better base model. So GPT-4 versus 4.0.
Okay.
And more compute.
Okay. And that's the other thing I wanted to, before we run out of time, and then we're going to talk DeepSeek, like the compute problem. Compute meaning what? It's hanging out in more GPUs and expending more GPU cycles on multiple GPUs.
Yeah. So when we're training a base model, we need a bunch of data. So the amount of data and the quality of data that we have matters. So those are two important dimensions. Once we feed I'm simplifying a lot of this. Once we feed all of that data into the training system, we can just let it run for longer. Right. So it's fairly logarithmic. In some cases, can just be linear or even exponential. But really, if you look at any training chart, like it gets a big increase and then it kind of slows down. And they could just keep training this for months and months and months and months and months, and it will get better. To a certain extent, there are
asymptotically better, like it will.
All these, but it might asymptotically get better, but it probably does just kind of get better. But there's this kind of like trade-off of like the actual cost of continuing that versus the improvements to it. And so eventually you just kind of say, okay, well, it's good enough. We don't think the trade-offs are worth it, and that's like, okay, we'll release this model. But again, you can just keep doing that. So if knowing that you can just keep training it for longer, if you release a better chip. So if NVIDIA now releases GB200s versus the H100s, you can just do it you just throw more compute at it. You're doing it for longer. So you can do it with better chips. You can just extend the training time, so you can do it for longer. There's energy cost in doing that with weaker chips, but there are a couple dimensions there that you can improve. But again, having better chips and just training for longer just gets you a better model. So that's on the initial training. Sorry, go ahead.
I just wanted to, like, one last thing that will, I think, play into the DeepSeek stuff is that the GPU limitations and Grok kind of overcoming them. Like, do you want to just talk about that, because that's also like how many GPUs you can have?
Yeah, it's again, without getting too technical here, Grok when they were training 2 had some interesting innovation in that in the past we couldn't connect enough GPUs together. So when companies like OpenAI are training these models, we're not talking about like 1 or 2 GPUs, we're talking about thousands. And it used to be that based on the technology that we had, we could connect probably at most around 16,000 of them. You couldn't actually connect anymore because the trade-offs of like, they're not actually physically connected. There's some wiring between, and now it's slowed down. So you couldn't connect more than say 16,000. Grok, when they were training 2, really overcame that. They were like, well, why do we have this limitation? Why don't we just spend some time building around this? Really just by connecting them through Ethernet and a lot of other work that we don't need to talk about. They really broke through that limit and really have now made it, we don't yet know what the new limit is. So they trained Grok 2 on a 20,000 GPU cluster. They're now training, or have trained, Grok 3 on a 100,000 GPU cluster. And this is really what now has also kind of led to like the Stargate announcements of like, well, we'll just throw 100 billion multiple data centers at this. Like, we'll throw millions of GPUs at these things. There isn't, we don't think there's that limit anymore. And so now you can throw faster chips, more chips, and either do it in shorter time or keep it the same time or extend the time, and you just get more training. So more total compute, more total GPU hours per model. And so that gets you your base model. Now, your base model can then be supervised, fine-tuned, which is using high-quality human annotated data. So if you're ChatGPT and you've had all of this, every so often, if you've used it, you'll get like 2 responses, and as a human, you'd be like, choose this one. Or even just in your conversations with ChatGPT, you can kind of say, oh, okay, I'm going to assume I'm right because the human continued this conversation, for example, or didn't say I was dumb or wrong. So you can use high quality data to continue training, continue fine tuning. And so you've got your supervised fine tuning layer. What now DeepSeek has done, we'll talk a little bit about that. They just kind of re-added reinforcement learning on top of that. And so you can, there's the pre-training, which is your data and the amount of compute. There's your post-training, which is your supervised fine tuning. And then once you have your model that you release, when you use ChatGPT 01, you're using the model. And now there's the inference time side of it. And the inference side of it is, how much compute do you throw at inference? How many iterations, recursive iterations, do you say go and think for longer? And so the difference between O1 Mini, O1, and O1 Pro is very much just a compute. O1 Mini, maybe it only does it a couple times. O1 does it a few, and then O1 Pro just spends a ton of time thinking about it. This is not an exact correlation, but the idea is the same. That you just throw more compute at it, and your answer is just better.
So when we recorded, as of recording of this, last week Friday, DeepSeek, or last week, DeepSeek. This is January 28th. So DeepSeek dropped that the hedge fund spent $5 million US or something building a thing called DeepSeek, which is way cheaper and as good as, if I'm not mistaken, O1 or 4.0.
Yeah,
O1.
so
it's O1 good.
The specific term, it is DeepSeek's R1 model, which is essentially their reasoning model. Back in December, they released DeepSeek version 3, V3, which is their base model.
The reasoning model then competes with O1, obviously, and it is almost as good. Spent $5 million bucks. And as of the beginning of the week, NVIDIA's shares dropped, presumably because people don't need them. And actually, I saw this morning that energy stocks dropped because they're like, well, we won't be able to sell energy to data centers. But it's freaking everyone out because all the money that was poured into this thing to build these things. So I guess the question is, what did DeepSeek do differently? Let's get past the like newsy headlines. And what did DeepSeek do differently? And did they just steal all that crap from?
There were, I guess I'll also caveat that, but because they released their papers, and this is all in open source, they didn't release their data, and they didn't release some of the actual like training algorithms, but it is open source, and they did release a paper, so we do
So
have
they're
a
more
good
open
amount
than
of information.
OpenAI, and arguably what OpenAI was supposed to be.
Correct.
They're more open. And
But well, I won't go down
okay.
the line of openness. But because it's open source, we do have some information, but it's not like the scientific community doesn't know the exact reason why. Like there were some innovations, but it's not clear that's like, oh, it was this that made the model better. But so when you talk about their base model is a better version of, say, other people's base model. Because it's a newer model, DeepSeek was able to take all of the latest and greatest kind of research that had been out there and say, this is how you build good base models. But they did actually make a couple new innovations as well. We don't need to get into like super, super deep on the technical side of things, but there were three technical innovations that they had. One was called multi-headed latent attention, which is a improved version of multi-headed attention. They had a better version of mixture of experts. They just called it DeepSeek mixture of experts. And then they had essentially a load balancing. I can't remember the term, something about auxiliary load balancing on the experts. All of these weren't like crazy new different ways of training, but were very refined or improved versions of each of those, improved version of attention, improved version of the mixture of experts. And so all of those innovations led to better efficient, like in some cases, pretty significant efficiency. So they could train a better version of their base model with much less compute and much less quality of data.
So two questions then. One is, they obviously don't have the data sets that they didn't slurp up the internet, at least not that I know of, or they don't have proprietary data like Apple or Google have because they are the internet. Go ahead.
This is a relevant question. You're kind of asking, like, where did their data come from? So obviously they had some publicly available data. There's some pretty common data sets that everyone uses. But we should talk about what distillation means. So when essentially they trained their model on top of the existing ChatGPT. I actually think they used Meta's Llama and Alibaba's Quen models. Basically, they used those models as like the teacher model to teach it what its data was. So they kind of like asked it a bunch of questions and extracted all of those answers from those models and used that data to train their model.
So is it safe to say, but for the fact that those models exist, you couldn't have built DeepSeek without something, without.
Correct. And this is the world of fast followers, is that initial, like the technical innovations aside, you can build a distilled, and you actually see tons of distilled models out there.
It's confusing actually, because if you go on LM Studio, which is a free, I think, open source client you can download on your machine, now you've explained it, because it's like, would you like DeepSeek Quen or DeepSeek Llama? And I'm like, I don't know.
Yes. And think of the best way to think about the term distillation is like a copy of another model, but a compressed and smaller version. So it will never be better than that model in terms of accuracy. But for the most part that most people are using, it's probably 95% as good. Maybe in like the super obscure math things, it's worse. But again, for most people,
why do I care? Like, just curious, as a user, if you're going and downloading a model locally and you've got Quen and Meta, like, what the heck? Why do I care?
Yeah, and so in the open source world, you'll also see distillation of a size. So the actual DeepSeek R1 model is, I believe, it's like a 407 billion parameter model. There is then a 70 billion version. There's a 40, a 32, 16. I think there's a 1.5 as well.
And that means specifically? It's like the size.
The best way to think about it is the size of the model, number of parameters. As it matters, it's like, what can you run it on? So a small model, like a billion parameter model, could be run on your mobile phone.
Yes.
7 billion model or 16 billion model could probably be run on your laptop. 70 billion or 407 billion model needs to be run on NVIDIA's digits or a GPU cluster.
I definitely tried to think of 32 billion and it destroyed my Mac Studio, which like it just froze, which seems kind of like, why would
and so the consequence of the smaller models is, again, less accurate output. Sometimes they just release garbage.
Yes.
So
it's righter or better the larger it is, which is why you want to pay some, like you're using data center somewhere when you're asking ChatGPT, because if you're using O1, you couldn't run that at home.
This is the dimension of anything. If you're looking at paying for ChatGPT versus ChatGPT Pro, or so free versus the premium versus the Pro, the only thing really you're paying for is more compute and more accurate answers.
So So okay, so got it. So it's like it is kind of like we don't need to necessarily get into the the training stuff because I'm just nerdy curious. But using an existing LLM that was trained with heavy metal, like NVIDIA GPUs and whatever, they trained using newer ways of training these or creating these things using they didn't have data. Did they have separate data sets? They had probably some
Well,
open source
they
data
had some
sets,
base data
but they didn't
sets
have
that
anything
everyone has.
proprietary or special
Yeah. Yeah.
that you couldn't just get off the shelf. And then they took
No.
what exists today and trained their own thing. And the $5 million was
Well,
spent.
and so sorry to be clear, that was for training DeepSeek V3, which is their base model. Their base model is then used to train their reasoning model, which is R1. So there again was some innovations there. So in order to train R1, a reasoning model, they mostly use synthetic data. So they had, say, a couple thousand examples of human annotated, like long chain of thought, like good quality data that they could have fine tuned a model. But what they did was they took V3 and they using reinforcement learning, they basically created a new data set of long chain of thought reasoning, and then used another reinforcement model to find the highest quality version of that. And so they ended up making what was called R10, basically a precursor model to R1 that then they retrained V3 on. So V3 created R10, and R10 then retrained V3 in a better way, basically saying, "Oh, this is how you think about chain of thought. This is what matters." So then that created a new chain of thought data set that then they could actually then use supervised fine tuning that most other folks use to then create the final model. So it was interesting that a lot of the chain of thought reasoning was synthetic data. And they had built this precursor model that retrained the base model. So you've got this, again, circular loop of AI essentially training AI. We'll get to the point of AI training AI, so that you build a better base model, build better reasoning. Better reasoning model can build a better base model, build better reasoning model. You just keep down that path. And so the $6 million cost was the actual training cost run of R1, the one that they released, assuming they were using what was it, 2048 H800s at $2 an hour. So it was like a simulated cost, but all of that was just the cost of that one training. It's not the cost of all their salaries. It's not how much they've raised. It's not how much, like, the cost of V3 was probably the same, if not more than that. It's like they've spent a ton. It's not the hardware cost. There's tons of other costs. This is not just like they're a $6 billion or a $6 million company competing with like a $6 billion company. Like that is just the actual cost. If you or I wanted to do the exact same thing with their data, it would cost us $6 million to train R1 version 2.
Got it. So like, the $100 billion or $500 billion data center they want in the States, for example, or the $2 billion in Canada that there's putting in hardware costs.
It's all of this. It's hardware, it's infrastructure, it's energy, right. It's people and operations and the actual training, like and research, like it's all encompassing.
So, what's freaking everyone out is that. So is it, so anybody, clearly $5-ish million-ish dollars-ish plus or minus, you could create. So it used to be the case that the moat potentially was gigantic amounts of capital, and not maybe $5 million, but it's not $1 billion or $10 billion, right? So now there's even less of a moat for anybody to create a base model. To an extent, you're never going to my understanding then is you need these frontier or whatever you want to call them models you need the capital to be spent to create AGI. You can't $5 million your way to AGI, probably.
Correct. Yeah.
You need these other models to then train the new ones. So somebody else needs to spend money that you can barnacle off to do your own thing. Yeah. So they're not, at least.
And there is value in that. Like we talked a lot about this. So for a general consumer who just needs answers or who's going to use it for search, maybe the DeepSeek is good enough and they never have to pay for anything again. Like that's fine. But there is so much research and innovation to be done by these models. Longevity, cancer drugs, like there's so much that we humans are not really able to do at scale, that if the AI can do it, obviously that opens up worlds of possibilities. And that's what these larger companies are building. Like that's why they want AGI. That's why they want ASI. They don't want to just put everyone at a job. Like it's not zero sum thinking of like, there are 100,000 different jobs in the world. Let's automate 100,000 different jobs. And now no one has a purpose of work. like that may be a byproduct if you took a snapshot
Yes.
of the world and they build ASI, but like that's not their goal. Their goal is to solve all these problems that we as humans can't solve or haven't been able to
So
solve.
is Meta's the only one who's, I think it's Meta was the only one who's like, here it is, it's free ish.
Yeah, open source. Yeah.
And they're giving it away for it's a different business model. It doesn't really
Correct.
mess with Meta's end goal either. Then they're giving it away for free, but
No, because
their end
Meta's
goal is
end
not to go
goal
ahead.
Meta's end goal is building the multiverse.
Yes,
And again, that is you can't have enough programmers like build enough 3D models to build enough worlds that builds in. So you have AI do it.
right.
So Meta's end goal is, well, let's just build these models, get other people to build better models
And we'll
and build
absorb
tooling
those
around
and
this so that we can build
crowdsource your metaverse build
yeah,
rather
yeah.
than right. So going well over time. What this week, people are freaking out about it. I imagine then that while all those companies are nervous about them, they still understand that they're playing a different game. The people who should be nervous as a result of this, should anyone be nervous?
Again, remember, it's we started this conversation and I said, when you take money from an investor, or when you're trying to take money from an investor, you have to think about who that investor is. There's a spectrum of investors. I care about building this utopic version of we've solved everything and I live forever. Many investors may be looking for, so NVIDIA dropped 17% yesterday. Many investors who are in that might be like, well, I've invested in NVIDIA because I think they will be GPU compute constrained by the end of the year.
Yes.
And if they aren't, well, that's a bad investment.
Right.
This might have opened the door to, well, now maybe people need fewer GPUs. And so now people won't buy as many NVIDIA GPUs and then they won't sell everything that they're making. I personally think that's a silly argument. I think they're still going to end the year GPU constrained and continue innovating and building there. But again, different investors will have that different perspective. And that's why I guess most are in it for the short term, like give me
right. But the door that's open
20.
for not Apple, Google, not FANG companies, I suppose, or whatever they're called today. Maybe it's MAGA. I don't know. Is that you or I could create our own models ourselves. One more question there. Why?
Probably not build our own models, but just we now have a cheaper way to innovate at the application layer. So if I'm building an AI BDR, I don't have to use
OpenAI.
Whatever OpenAI's latest thing is that's costing me. I now have a essentially free version that I could rent some cloud GPUs.
But I mean, for a relatively not billions of dollars cost, if I wanted to train my own base model, for example, and just follow whatever DeepSeek did in terms of step by step.
Yeah, you don't quite have enough information because you don't know their data.
Why would they not? How is it open source if you're not releasing like the weights or whatever?
Well, they released the weights, so you've got the model, and you can fine tune off their model, but you can't recreate what they've done.
Sure,
it's maybe a better.
But if they fine, are they not? What's stopping anyone though from creating their own model? Other than investing their time and effort, like if you just follow the steps they took and took the modern research and just invested time and effort, you could create your own model. No,
sure, yeah.
You have to be bothered to do that.
Yeah, if you had a reason to do that, say because this version of the model did have some censorship around it. Not talking about the actual like DeepSeek app, but talking about the actual open source model, there is still some censorship. I think already there have been some folks that have like fine-tuned the model to try to get rid of that censorship. So yeah, like if there's a problem with the model, you can continue to build on top of it and fine-tune it and make a better version of your model. If you feel like you can't do that and you need to rebuild what they've built, yeah, there's still value in doing that. It depends on what the purpose,
the point of it. But I guess the only thing that was not obviously possible until today was like, yes, prices were going cheaper. They went cheaper quicker. So that affects the business models of all these other folks. But the material difference now is the new research and technologies in the last year has allowed people to create based stealing. I'm going to say steal. Utilizing those existing really expensive models, you can train something. I'm sure part of the $5 million was paying I guess Llama runs locally. So you could technically do a thing that you couldn't do without billions of dollars 2 months ago, right?
Yeah, I think really what DeepSeek releasing R1 at essentially the quality that O1 really reinforces is that it's not just the three scaling laws that Jensen talked about, but there is a fourth that I think we see all the time, that it's algorithmic improvements. If you continue to build better versions of the underlying algorithms that train these models, they can be more efficient. There's tons of optimization to be done there. And we don't just have to throw compute at it. It's not just throw energy at the problem. It's not just throw $100 billion of GPUs at it. It's use some of that to bring on researchers and continue to innovate and bring on actual programmers and make it more efficient. Like there's tons of optimization to be done there. And that will lead to that one alone would lead to significant improvements in the models. So.
And just one last thing before we get to the end. Why wouldn't the existing AI providers have come up with this? Why are they, is it just because they're not, is it a blind spot, or this is not the kind of direction they want?
No, like all of these different research labs are all researching different things all the time. These folks just happen to maybe spend more time researching algorithmic optimizations to base models rather than how to build the O4 equivalent of a model. Which I think was smart. Like if they're trying to build an open source cheaper version that might make it so they can get to O4 sooner, they probably have to start by building some way to accelerate their growth, and so they've accelerated. Now they have all of the foundational pieces that they need to build maybe something that is better than what OpenAI could build. And that's not to say that OpenAI is just doing the wrong thing or working on the wrong problem or aren't smart enough. They're working on different things, different problems. And this, I guess maybe I'll end by saying, like, this is the potential of AGI and ASI equivalent or quality models, is that it's just another researcher. It can think about different things, maybe even at a different scale. There's no end to the amount of smart people that we need building new things and trying new things. We can just have more of them. This is not, it's not like we only need 100 or 1,000. Just keep building more and more and more and more and more, and you'll get more and more and more out of it.
It's funny because it's like Apple, when Apple was like, "Oh crap, we're not letting our employees use ChatGPT. We're going to build our own." I bet you I don't know what they did. They caught up ish. They're still not anywhere near what those are, but now they can just do it. So going forward, and then we're going to talk next month, and we'll see what happens. But what do you think this does, if anything, to the way that technology is being built, like technology companies are being built, and does this change anything about your approach for the next month?
I don't think, no. I think if you're the type of investor that this changes things, then you probably weren't thinking about the end goal, the future in the right way. You were thinking too short term in how can I extract consumer and business profits from the people using AI subscriptions today. It's not the world of possibilities that it opens tomorrow. And so does it change anything in my life? No, not at all. I only am more excited that you can do all of this cheaper, faster, and better. And if maybe last week people were hypothetically saying in 2 or 3 years you'll see AGI, well, maybe that accelerated it by another 6 months, and isn't that exciting?
Yeah, that's really cool. All right, well, thanks for taking the time to talk to us. Me,
Us.
I am a plural now. I am royal, and we'll talk again in about a month and see what the hell else happened. But great to see you, Ryan. Thanks for coming. And where if people want to find you, where do they go to find your fund?
shn.vc, santalnorth.vc or .com, or email me, or LinkedIn, or X, or in person.
Find me on the street. Cool. Yeah. Well, I'm looking forward to hearing what's happened both theoretically and practically in your life in the next month. Thanks for the time.
Take care, Rob.
Thanks for tuning into the show. We really hope you enjoyed it. Don't forget to like and subscribe. I'm legally obligated to tell you that. Leave a comment below if you have any questions or you want us to hit up on specific topics, or go to decelerator.media and get in touch with us if you just want to talk. Have a great week.